Hello all. Welcome to the third episode of the Kickstart VMware Cloud Foundation project series. I'm Satya Shrestha, a senior staff executive services architect at VMware, and I'm here with my colleague Vincent Han. In today's episode, we'll be going further into our conversations around Kubernetes within and on VCF. Welcome to the episode, Vincent. How have you been?
Hey, hi Satya. I'm fine. How about you?
I'm good, man. I'm good. So we've done 2 episodes so far. So what have you been hearing about our episodes?
Yeah, I think other than the views that we got in videos, right? I think a few of fellow colleagues has asked us for the slides, and yeah, I think that's good news, right? So
yeah, absolutely happy to share these slides or contents that is helpful for others. Yeah, by all means, man. It's good to hear that.
Yeah.
Okay, so for today's episode, before we begin discussing about it, let's briefly review the key points that we have done in our previous episode. We dived deep into the topic of supervisor clusters in TKGs, and we examined their role and how it interacts with different components of TKGs. We also examined the architecture of supervisor clusters in TKGs cluster, as well as various components that constitute these clusters. We discussed how supervisor clusters play a critical role in simplifying the management and operations of Kubernetes clusters within the TKGs environment. Vincent also showcased a live demonstration of deploying, configuring, and managing supervisor clusters within the framework of TKGs on VCF. If you didn't catch our earlier episodes, please be sure to explore them on our VMware Cloud channel to build a solid understanding of Kubernetes in and on VCF. Okay, so next up in this episode, we'll be discussing load balancers and ingress controllers within the context of TKGs cluster on VMware Cloud Foundation. We'll explore the important role that load balancers play in managing Kubernetes workloads within VCF. So Vincent,
Yes.
Can you provide us more information about the load balancers and ingress controllers, which is essential components of TKGs clusters?
Yeah, definitely, man. Really happy to do this topic, right? Load balancer, ingress controllers. As you know, in my previous role, I'm taking care of networking and security, right? And I spend quite a fair bit of time on doing load balancer and ingress controllers for Kubernetes, right? So really happy to share this topic with everybody. Yeah, so probably the next few slides, we will just do a recap on what we have covered so far. So this is on episode 3, right? On
Yes.
our advanced workload acceleration use case on VCF. And today we're going to just deep dive into all things load balancer, providing load balancer for Kubernetes clusters, TKGs, VM servers, and even vSphere pods. We will take a look at 2 solutions, right? The NSX and RV, and give you a comparison of what's this 2 load balancer solution is all about. And hopefully by the end of this session, you get to choose which load balancer that you want to use, right? So we'll start with some recap on the vSphere with Tanzu architecture. I think the next few slides we kind of covered in the last episode. I just want to maybe just do a quick recap so that you know what are we talking about in even for load balancer. So we covered the supervisor clusters the last episode, and it comprises of multiple control planes, and you can actually use it to create multiple namespaces, and each namespaces you could have a combination of TKCs, VM, and vSphere pods.
Mm-hmm.
So why are we talking about load balancer today? It's you're going to have multiple replicas of control plane, whether is it in the supervisor clusters or in the TKCs, or you have multiple replicas of VMs and vSphere pods. All this requires a load balancer.
Yeah.
Just like this slide is all about. So this is on the supervisor control plane. You actually need a load balancer to provide a high availability as well as load balancing across all these control nodes. So if one of them fails, then the load balancer will be able to redirect the traffic to the working ones.
Exactly.
So same thing for workloads as well. So this will be your application users assessing. So whether you are using vSphere pods or you are using VM servers or you're having pods in the TKC itself, same thing. You actually need a load balancer to load balance your user traffic to all these multiple replicas of pods. Okay.
Basically, load balancers are crucial even for your control plane components as well as your applications, which are user access, right? Basically, that's what we are presenting here.
Correct. You are absolutely right.
Yeah.
Just to recap, we talked about these 3 options of load balancer in the previous episode. So Kubernetes don't have a built-in load balancer. So you actually have to provide the load balancer as a prerequisite. You have the option of using HA proxy, but that is actually good for home labs and POC. So we talk about production environment for our customers and partners. So we're going to focus on RV and NSX over here. So these 2 solutions are definitely production ready. Hopefully you get to choose what you use, like what I said before, by the end of this session. Okay.
Mm-hmm.
So let's talk about the NSX load balancer. And this is also known as what we call the native load balancer in NSX. So if you are NSX Enterprise or even Advanced Editions previously, you have this option to use the NSX load balancer, the native load balancer.
Right.
So in a vSphere with Kubernetes construct, how it actually does is obviously you have to use NSX, right? So that you have the capability of using the load balancer, okay? So in NSX, you have the tier 0, tier 1. So tier 0 is basically the router that face a physical network that you have. And tier 1 is basically like a distributed router for your workloads. So in the case of TKC, right, you have multiple control planes if you spin up clusters, and you actually need a load balancer for it. So when you actually configure your workload management in vCenter, and they will actually bring up this load balancer for your supervisor control plane as well as your TKC clusters as well, right? So all this is being run on the tier 1. You activate any of these services, whether it's for tier 0 or tier 1, they will be running in the H nodes itself, right? So H nodes is a construct in NSX. You have to create all these H nodes before you can actually create all these virtual routers, right? Tier 0, tier 1, and things like that. So let's deep dive a little bit in the H cluster. So because this is where the NSX load balancer actually runs. So you have H node 1 here and the H node 2 over here, so 2 nodes. And when you activate the load balancer, you will have to attach to a tier 1. And that's where you have the active load balancer as well as hot standby being created. And they are created on 2 separate H node, right, for availability purpose. So let's say, for example, if one of the H node goes down, the hot standby will take over. You can create multiple load balancer, right? So these are like virtual load balancer instances running in the H node itself, right? So, for the first pair, active is on the H node 1, and then for the second pair, the active instance will be running on H node 2.
And most probably they will be running on different hosts as well, right?
Yes, the H node will also be running on different EXXI hosts.
Yes.
On the H nodes can also be in a bare metal. So, different bare metal nodes, right? Yeah. So there is actually HA messages going through across the H nodes. And the hello messages are sent in a different interval, right? So H nodes, you get much shorter interval, every 0.3 seconds. And then for VM, is every 1 second. So why are we talking about this? Because this is an active standby architecture. So all your, for example, the VIPs that you created for your TKCs are all running active on this H node itself. If there's any failure, the timer will actually affect the failover timing. Right? So it's about 1 second for bare metal H nodes, and it's about 3 seconds for VM H nodes.
Yeah. So basically it's measuring 3 heartbeats, and if didn't get the heartbeat for 3 consecutive time, it will just fail over that active node to the next one, the hot standby, right?
Correct. Yes. So of course, there's still failover to be done, correct? But it will be very limited in terms of the data plane impact because the states are actually synced across the H nodes, right? So these are some of the things that's being synced. Yeah. Yeah. So just to summarize, it is the architecture of LB in NSX, right? Is on active standby, and just get to be aware of that.
So what is the downtime here? If let's say that failover happens, what is the downtime for the application?
Yeah, so it's about 3 seconds, right, on a VM.
Very minimal. That's what it is, right? Yeah. Okay.
Yep.
Got it.
So let's talk about the layer 4 load balancer for Kubernetes. Okay, and this is actually, kind of like already integrated with the vSphere with Tanzu. Okay, and the integration is done via this thing called the NSX container plugin. So why is this important? Is because it's all automated, right? So if the user were to create a supervisor clusters or a TKC, the control planes need to communicate with the NSX container plugin, or it tells the NSX manager to create the objects in, if it's a load balancer, you would ask it to create the virtual server, create the server pool in the tier 1, the load balancer in the tier 1. Okay. So this is how the communication actually flow.
So now in this diagram, this is for NSX load balancer, right? So if you are to use NSX load balancer, it's through NSX container plugin. How does that NSX container plugin get deployed in TKGS cluster?
Yeah, so it doesn't really install in the TKGS clusters itself. It's more of running in the supervisor control plane. Everything goes through the supervisor control plane. So if you create a TKC clusters, so the NSX container plugin will watch it. And if you create a TKC clusters, you will actually go and create the VIP address for the TKC clusters.
Yeah, sounds good.
That's for NSX. So we'll move quickly to the RV. And for those people who not too familiar with RV, I'll just do a quick introduction on what's RV all about. So this is the architecture of RV, and it is software defined as well. You have the RV controller. So this is the brain of the solution, and this is the controller. And this is where you have your centralized place to put your policies, your configuration, and take care of the lifecycle management of the load balancer itself. So it actually manages the load balancer. So this objects over here, this is the data plane, which is the load balancer. They can be in different form factors, bare matter, VMs, right? All this is being managed by the RV controller itself. And when you create any virtual service, the RV controllers then will go and configure the service engine. So it's kind of very similar to NSX as well, right? NSX, you have the NSX manager, which is basically the controller, and the H nodes is actually the data plane. So in this case, for RV, it's very similar as well. Of course, it has many other features. When you compare this with the NSX, there's rich analytics, right? It's really easy to do the automation. We have a lot of, it's RESTful API as well. You can get snippets of Ansible or even Terraform code, and then you can actually, put it into the controller, and that will help you with the automation of the service engine and the virtual services and things like that. I'm going to talk about the elasticity. This is where it differs itself from NSX, okay? In the RV solution, it is an active setup, right? So you could have multiple service engine all running in active. This is different, like what I've shown before, as compared to the NSX, where they run in an active standby setup. So this is going to help with the availability of your services in RV. The VIPs that's running for your workloads are actually being distributed across multiple service engine. The more you distribute the services into this service engine, and if one of the service engine fails, like animation is shown just now, right? It's one of this. The services will actually get redistributed to the working ones.
Right.
And it's failed for a long time. The RV controller will detect it, and they will actually go and create a new instance of the service engine automatically. And then the traffic is being redistributed again automatically without any user intervention. Yeah. So if you think about this, it's like, since my services are distributed across multiple nodes, so when one fail, less services will be impacted. So if you want a highly available service, then the active setup in RV is going to benefit you.
Yeah, absolutely. For the mission critical workloads that needs high resiliency and auto healing features, this looks really good.
So other than the load balancer features that RV has, it also has a lot of other features that is important when you are doing Kubernetes. So for example, you have a multi-cluster setup. That's where you probably want to use GSLB. For security, you might want to have a web application firewall. It also has the web application firewall, the WAF capabilities. You can do rate limiting and things like that for your applications.
Yep.
Of course, it has all the integration with Kubernetes, right? So that's where all the container ingress services comes to play, right?
Yep. That is super important for Kubernetes and container world, right?
Yeah.
Controls. Yeah.
Yeah. Again, if you make the comparison between the RV and NSX load balancer, right? With RV, you get more feature-rich services. And this is actually very important, right? When you are running in Kubernetes in your enterprise, you need a multi-cluster setup. That's where you need GSLB, and you need security. There's WAF and things like that. Okay.
Yes. So for enterprise workloads that has mission critical applications running in it, I think Ivy is the way to go. And for today's load balancers context, also we will be covering more on Ivy, right?
Yeah, more on Ivy. Yes, that's right.
Okay.
All right. So we talk about the load balancer. It's going to be layer 4 load balancer, right? Whether you're talking about for supervisor clusters or for the TKC control plane. Of course, you can also create a load balancer for your VM service workloads as well, vSphere pods.
Yeah.
And let's now move into what happens to the workloads that you create in the TKC cluster itself, right? Of course, you can still use load balancer as a service, but a lot of times customers want to use Ingress because they can actually associate this with a FQDN, and it makes much more sense to the users when they're coming in, accessing the applications running in the clusters itself.
Yeah.
So let's talk a little bit about Kubernetes Ingress. So what is Kubernetes Ingress? It actually exposes HTTP and HTTPS routes from your cluster to the outside world, right? So you have pods running services, and then you create Ingress, like what I showed in the right. You have a FQDN name.
Yeah.
And once you specify that, your client can actually use that to access your applications.
Yeah. And this is level 7 construct, isn't it?
Correct. This is a layer 7 construct.
Yeah.
You could also use it to configure, terminate your SSL TLS sessions for your applications. Okay. But in order for you to use the Ingress, you actually need an Ingress controller. Okay. So of course you have many options over there, right? RV itself can be an Ingress controller for your Kubernetes Ingress. Okay.
Right.
Then, of course, we need to talk about the RV Kubernetes operator. So basically, that's operator that provides the Ingress controller service. Okay. So let's now take a look at the architecture, what it actually does. So in your Kubernetes clusters, in your TKC clusters, okay, after you have created it, you have your application pods running, and you want, your developer wants to create an ingress, okay? So that's where you actually need to install the RV Kubernetes operator. So this runs in the cluster itself. And what it does, it actually watch the Kubernetes control plane. So if when you create an ingress and you put it into the control plane, the RV Kubernetes operator will pick it up. It will send, instruction to the RV controller, and the RV controller will then go and configure the load balancer.
Right.
This is slightly different from a lot of options out there in the market, because the service engine, which is effectively running the load balancer, it's outside the cluster. The scalability of the load balancer doesn't really depend on your cluster itself, right? So it's not competing with your workload clusters. It's actually running outside the cluster. So you can have like two different kind of scale, right? You can scale your service engine outside clusters. You can also scale your workloads within the clusters itself. So it's kind of separated and isolated from each other.
Yeah, it's really decoupled. That means it can be more agile and scalable, right? It won't have performance impact on your workloads because the load balancer, all of that is running outside of that Kubernetes cluster, which is really cool.
Yeah, exactly. So let's move on to a multi-cluster setup. We're talking about TKC over here, right? So one of the benefit of using vSphere with Tanzu or Kubernetes VCF, it's the ability to use TKC, which is lifecycle managed by a cluster API, which means you could create multiple clusters. It could be multiple reasons. It could be used for different line of business. And the other great use case that I see is, you could have different sites, and you could actually create separate clusters for the different sites. And you actually make replicas of the applications, and you can make it highly available across your multiple location or multiple sites using a GSLB, a DNS, right? That will help you to redirect traffic to different sites based on different algorithms, right? It could be based on weightage and how you want to distribute the traffic, or it could be still based on an active standby, a DR perspective kind of scenario, right? So that's where we have the RV multi-cluster Kubernetes operator comes into play. So RV, the AKO, it takes care of the ingresses, right? So basically, it's the configuration of the load balancer or the ingress controller.
Yep.
But then in this case, you have the GSLB, which is effectively the DNS to configure, right? So that's where you actually need AMKO. So what AMKO does, it actually goes into multiple clusters, look at the configuration, and then again, it communicates with the RV controller, and the RV controller will then configure the service engine. But in this case, the service engine is not the load balancer, it is running the DNS itself. With this AMKO, you can have multiple TKC clusters being set up, and you can load balance your traffic across multiple different clusters. Okay.
Yeah, so this is really a highly available construct. Now that AMQO, does it sit on each cluster? How does that work?
No, it doesn't sit on each cluster. You just need to pick one of the clusters, and the AMKO, and you provide credentials to the rest of the clusters, and AMKO will then be able to go to the other clusters and pick up the ingresses that you have configured. And then what it does is configure the RV controller, and the RV controller will configure the load balancer. Yeah.
Right. And then it does the global server load balancing. Okay.
Yeah. No, I mean the DNS, not the load balancer. Yeah.
Yeah.
Basically, just to summarize what we have covered so far for the RV, as you can see, for Kubernetes services, you actually requires multiple components, right? Whether in the form of Ingress, which is load balancer, you want to provide security services, you want to provide multi-clusters capabilities over multiple sites, that you need GSLB and things like that. DNS. If you have actually tried out with other solutions, you'll kind of end up like multiple different discrete solution itself. So what RV actually provides here is an integrated solution with all these different services itself. And then of course, I'm going to show you in the demo itself, which is the dashboard of the RV controller. That's where all the configuration is going to be, right? So you have seen, even for AKO, AMKO, it all communicates to the controller itself. So that's the single place where you manage all the policy configuration lifecycle of the service engine.
Yeah, it's very feature rich. Yeah.
Great. This is an integrated solution, which means that it's going to make your operations much more simplified, right? So you do not need to deal with, again, multiple different discrete solutions over there. I'll talk about the security. And last but not least is on the observability part, right? So as you can see, this is a single place where we actually configure everything. And this is also a good place where you start monitoring all the different components that you've created, right? Whether it's the GSLB, WAF, and all this. So with all these metrics that you get out from all these different components, then you are able to give you, great visibility, great insights to your applications. So if there's any outages where you actually requires to troubleshoot, it's going to make the troubleshooting much more easier.
Exactly. And the analytical engine that it has is also really great for finding the issues, performance bottlenecks, etc., right?
Correct. Yeah. So now we have covered about RV. Now we're going to talk about how is it integrated with vSphere with Tanzu.
Yep.
So this is something new pretty recently. I think it's maybe end of last year in 2023. We actually announced 8.0 U2. So previously, prior to 8.0 U2, when you use vSphere Tanzu with NSX, you will actually use the native LB by default. Of course, you can still integrate with the RV solution, but there's many other things that you need to do, right? So in 8.0 U2, the BU has made it much easier for this integration. And it comes with this NSX ALB. It has this NSX ALB onboarding procedure that you actually need to do, right? So it's a bunch of API that you call. You can run it on NSX Manager, or you can be running on a Linux jump host, for example. And once you do that, you will be integrated with the NSX Manager.
Yep.
When you create any layer 4 load balancer, it will be created in NSX ALB or RV. So there's a few prerequisites that you actually need to do, right? You need to be on, of course, a minimum of 8.0 U2. The NSX version is over here. And this is very important over here. You actually need the enterprise license for the RV controller. So this is very important. There's a few other things that you need to take note of, right? So in the NSX cloud, you need to make sure that you enable the DHCP in the cloud. And when you create the IPAM profile, you uncheck the allocate IP in the VRF. And the last thing is also very important. You actually need to update the certificate in the RV controller itself. So there's a few things you need to do. So once you do that, then the integration is done. So whatever that you create in the supervisor clusters, you will get created in RV. All right.
Right.
Okay, so let's go on to the demo.
Yeah, the most interesting part. Yeah, let's do it.
Yes, I have prepared 5 demos to show in this episode. And I'm going to group some of these demos because some of this is going to be very quick, right?
Yes.
So as you can see on the left diagram over here, so we have the supervisor namespace, and here we created another namespace. In my demo, I call it a namespace tree, right? And in the namespace tree, we have the TKC clusters, and it has a control plane. As you can see, there's multiple places where we actually need load balancer. So the control plane for the supervisor clusters. So I'm going to show you can actually use RV for it. TKC, you can also use the RV solution for it. All right?
Yes. And we mentioned earlier that we'll be only concentrating on AVI load balancer here, right? And all your 5 demos that you have grouped here, they will all be on AVI, isn't it?
Correct. Yes.
Yeah.
You have NSX running at the back end. So all these are on NSX itself, right? So that's why you actually need to do the RV controller onboarding on NSX.
Okay.
Again, I'm just going to show you. So you have the supervisor control plane over here. So these are the 3 nodes, right? As you can see, the way to log on to this supervisor control plane is I'm going to use CRI for it. Again, I'm going to show you the. Okay, I'm going to show you, right? So this is the cluster that I have over here, and this is the control plane node address, right? This is the VIP for it. Okay.
Right. VIP is virtual IP for load balancers.
Thanks for that. So it means virtual IP. Okay.
Yeah.
So I'm going to use the virtual IP to log into the supervisor cluster. Okay. So let's see. Yep. So I'm going to log into the supervisor cluster, and yeah, maybe I should just show you how it looks like. So yeah. So I showed this before in the previous video. So you basically have to specify the VIP over here, right, for your supervisor clusters. So let me log into this. Right. So once that I need to switch on to the context. Okay. So I get the nodes so that you can actually see, right? You have multiple control plane, right?
Yeah.
And let me show you the IP address. Okay. So these are the 3 IP address over here.
Yeah.
Okay. So I can go into the RV controller now, right? And I'm just going to the dashboard. This is actually the control plane. You can click on this and you can actually see, right? This is the IP address, the same address that I log on to, right?
Yes.
Yep.
That's yep.
Yeah. And with this, you can actually expand. And these are all the nodes that I show you, right? You can verify nodes IP address. So this VIP itself is actually load balancing across all this multiple nodes itself.
Yeah.
Right? So this is the supervisor cluster, the supervisor control plane. Okay.
Right.
Yeah. So that's the first demo that I'm going to show you. So once you have a supervisor cluster running, right, you can create a TKC clusters. So you have like what I say, you have to create a namespace here, and I have 1 TKC clusters over here. I created 3 control plane and 3 worker nodes. You can see over here. Yeah. So again, there's multiple nodes over here. So you actually need what do you call that? Again, a load balancer to load balance across all this multiple nodes itself. So
Right.
again, I'm going to log on to the guest cluster. So I'm
Mhm.
just going to have a shortcut over here, right? So now I'm changing my context to the namespace tree. Okay.
Yeah.
I'm going to get nodes again.
Mhm.
So you can see that there's 3 control plane nodes. Okay.
Yeah.
So again, yeah, so these are the IP address for the control plane.
Yes.
Right? We have, let me go back to the RV side. Yeah, so this is the control plane service. So you expand over here,
Right.
828789, right? So this is the one.
Yep.
828789.
Yeah, that's right. Yeah.
Yeah. And yeah, so this is the VIP for this 3 control plane nodes.
Yeah. Okay.
Okay, so yeah, so as you can see, RV is being utilized as a layer 4 load balancer across the supervisor clusters as well as the TKC control plane. Okay, so let's move back.
Can you also show the YAML that actually you use to have that association?
Yeah, you don't really need to specify it, right? So basically the VIP segment was part of the supervisor creation, which is probably covered in the previous episode.
Yeah, right.
You actually create Ingress subnet for it, right? So
Okay.
all this VIP that you see over here, right? And just make it smaller. This actually all comes from the Ingress subnet that you have specified.
Yeah.
So let me maybe log on you see whether I can show you that subnet over here.
Yep.
Yep, here. So this is the subnet. So once you configure this in the supervisor clusters, so the layer 4 address will actually comes from here.
Right.
And it's being used in the RV itself. You can see over here, right?
Once we mention that ingress there, it automatically plumbs that to the supervisor clusters, right?
Right, yeah.
Got
So
it.
there's no mention of it in the YAML file itself. Yeah,
Okay.
I can show you the YAML file for the TKC. Let me see. Yeah, so this is the one that create the TKC, right?
Yeah.
Yeah, so we're going to deep dive more on this TKC cluster on the next episode. But like what I mentioned, you don't really need to specify, what you call it, the VIP over here, right?
Yep.
So those are all being managed as a kind of like an IP address management being managed by NSX as well as RV, and those are all taken care for you.
Got it.
Yeah, so those are all automatically assigned. So it's a pool address, right? It's a subnet, right? That's what we've seen in here. It's a subnet, and basically, NSX as well as RV will just pick one address from here.
Yeah, good stuff.
All right. Okay, so let's now move on. So now we are moving on to the workloads itself.
Right.
So we're going to go into the clusters. So again, like I mentioned, in the cluster itself, there's multiple ways that you can actually create ingress to the cluster. So it could be in the form of layer 4 load balancer. It can also be ingress, right? I'm going to show both. Okay. So now I'm just going to show in the clusters. Okay, so yep, so I'm in the TKC cluster. And I'm going to show you the ports that I have. I have some demo ports here. So I have Hello Kubernetes. I have this Nginx one that I've created. And I'm going to show you the services. These are the services, all cluster IP. I don't have anything that's external that's coming in. So for the next demo, I'm going to create an external service for it's a service type load balancer for Nginx one.
Yep.
Okay? So I prepared the command over here. So you basically you can just use the expose and you specify type load balancer, and this will get exposed, right, as a layer 4 load balancer.
Yeah, it's the same Kubernetes command, right? Yeah, good stuff.
Correct. Right. So once I do that, you can see that in services, okay, it's still pending because it's trying to get the virtual IP from RV itself.
Right.
Now you got it. Okay.
Yes.
Over here. So we can go into RV and we can see
8.6.
Oh, here.
Yeah.
Right. So 8.6. Yeah, 8.6, and this is the one. And you can click on here, So this is the dashboard. This is the analytics that we talked about.
Yeah.
Of course, I just created this. There's nothing much to see. Of course, you can see the logs.
Yeah, right.
Yeah, so I'm going to enable more things like real-time analytics, and then I'm going to show the non-significant logs, right?
Okay. Yeah. How about we try to browse something there?
Yeah, correct. Right, so this is just entering, do a few more requests.
Yep.
And you see that. There you go. Right, you can see, the exact traffic is coming in. And then you can see that, where is it coming from? So this is the internal client. There's not much information that you can see. But, if you use it on the internet, then of course you get to see, where the client, the location is coming from and things like that.
Yeah, right. So that virtual service IP 10.250.8.6 was already created there, or did it get created when we invoked that nginx expose command?
Yeah, when we did the expose command, it was
Yes.
already created, right? So over here, right?
Yeah.
Yeah. So I'm just creating what do you call it? I'm just generating some traffic.
Yes.
And that's already there, and you will just send it to the virtual IP.
Okay.
And you will send it to the ports as well at the back end, right? Over
Yeah.
here.
If you can go back to your Kubernetes command line, let's say if I create another nginx, let's say nginx 2, right? And I also did another expose. Does it go to the same virtual IP, or will it create another virtual IP?
You will create another one,
Mhm.
because if you create a different service, then of course you will have a different virtual IP, right?
Okay.
Yeah.
Okay. And Avi will give us a separate IP address automatically for that, right?
Correct. Yeah.
Okay. Good stuff.
Yeah. So this is slightly different if you use Ingress, which I'm going to show you later on. But if you use Ingress, is the shared pool. That's where the next demo that I'm going to show, I might as well show you over here.
Yeah, right.
Yeah. So this is the shared pool. So when you create an Ingress controller, they will create a different service, right?
Okay.
And the Ingress will get sharded across multiple service engine, and these are actually shared. So the VIP for Ingress is actually being shared. Right? So it's slightly different from load balancer, right?
Got it.
So now, previously you have seen the ports, which is the Hello Kubernetes, correct?
Yeah.
I already have created the Ingress, right? So you can see I have created the Ingress over here.
Right.
And yeah, so in this case, you can actually use the FQDN over here.
Yeah.
So let me show you. Let me correct.
And is that DNS service also coming from Avi?
Yeah.
Okay.
Yeah, you can, but I'm just doing a static one on my machine.
Okay.
But yeah, you can use the DNS service on Avi itself to provide this, right?
Got it.
Yeah, so you can see that I'm actually using the FQDN to access the applications. Maybe I will show you. Let me see. Is it? Yeah. So that's the Ingress, right? And let me show you. Yeah, if you're interested, like I can show you the YAML file, right? Yeah, so this is the YAML file that I created. This is the cluster IP, and then have the deployment, right? This is actually deploying the ports itself. And to create the Ingress, you actually have to specify, I'm actually creating a HTTPS with TLS. So you specify this TLS specs, and then you specify the FQDN, and point it back to the Hello Kubernetes service, right?
Right.
So this is how it will be created. Whether is it the load balancer creation as well as the Ingress controller, right?
Yeah.
We have talked about it. Is the AKO that is actually doing all this translation, if you want to call it. I can show it to you what's running inside the cluster.
Yeah.
So you can see over here, right? There's AKO running in the cluster, right? So this is the one that's actually watching the control plane. And then previously when we do the expose, when you create the Ingress, the AKO will watch it, and then you will go and create the configuration on the RV controller itself. Okay?
Right. So basically, it's just an agent running there and sending the API request to the IV controllers, right? And then it does whatever it needs to do in IV controller itself.
Yeah. The installation of the AKO is really simple. So when you after you created the TKC, this has to be done as an additional step, but it's really easy to install the AKO, right? So I'll just show it to you over here.
Yeah.
Okay, I have made some simple scripts to install, right? AKO. So basically, you can use Helm to install the AKO.
Right.
So, and you just specify the version of it. So this is the configuration. So again, it's another YAML file.
Yeah.
Okay. And yeah, just show it to you. So a few things that you need to specify over here. So yeah, this is you have to make this a layer 7 only, right? Because layer 4 is being handled by the NSX part. You just use it as a layer 7, right? So this is configured over here. You need to specify it, right? That is going to be used.
Right.
And the rest is how you want the sharding to be done, right? You just basically configure over here. And the next part is, where's your controller, what's your username and password, and that's about it.
Right.
Once you create this value file, you do a Helm install, and AKO will get installed, inside here.
So this one, the AKO installation, what is the sequence? When do you install this?
So after you have created the TKC clusters, next thing you do is just install the AKO.
Right. That's even before bringing up the supervisor clusters, etc., right?
After you have created the supervisor cluster,
Oh, okay. After we have created the supply cluster.
So for the RV controller, yes, you need to set up before the supervisor controller cluster, the supervisor clusters. For then you create it. Once that's done, then you create TKC, right? So RV used as a load balancer for the TKC control plane. So once that's up, then if you want to have ingress services for your cluster, then you go and install AKO.
Oh, okay. Got it now.
You can see that RV is being used for multiple places, right? Supervisor control plane, TKC, for the workloads inside TKC using layer 4 load balancer, and now with Ingress. So it can be utilized in multiple places, okay?
This is like an all-round load balancer and Ingress control, right? This is awesome.
Yeah, maybe an additional thing before I move on to the last demo is, so since I have this Ingress over here, right? It's actually running on this shared Ingress controller over here. And it's actually running active, as you can see over here, right? This is where I'm going to show the differentiator between RV and NSX itself. You can do active, right? So let's say, for example, this tool is not sufficient for me and I need to do a scale out, right? And you can see over here, there it's scale out, scale in, and migrate over here, right? So really easy, I can just click on scale out. If there's a service engine available, they will use it and add it in the pool. But if there is none, then you will go and create that service engine itself.
Yeah. Is it possible to see how it's being created in vSphere also?
Yeah, sure.
So you can see that virtual machine getting created, right?
Correct. So you can see that there's a deployment after I scale out, and it's actually fetching this is the image, right? 22.15. I'm using 21.15. This is the service engine image, and it's now getting transferred to the host. And maybe I can show you that it's being created.
Version of the VM.
Yeah, this one, right?
Great.
Yeah, and this is actually being created in vSphere right now, right? So you can scale out easily in RV itself.
Yeah. One question. So if let's say you have resource contents on there within your Kubernetes cluster, will RV automatically detect that and then scale it out for us, or does it have to be manual like this?
You'll probably have to do with your monitoring and things like that. And you can actually scale out the clusters. So again, scaling out the clusters for TKC is really simple. You just need to go into your YAML file, and then you can actually edit it, and you just need to change your replica over there.
Got it.
So why not just show it to you, right? Yeah, maybe we can do that like in the next episode. I will scale out the TKC, right? I think it's more appropriate when we talk about TKC over there. But I will just show it over here. So basically, you can just go and change this to replica 4, even 5. Then your worker node will increase. Correct? So again, like what I said, you can do your scaling both on the worker nodes itself, and then outside your Kubernetes clusters, you can scale it in the RV, right? In the form of virtual machines, which what we have just done over here. Right? So
it's really cool.
I think this is a big differentiator over here. Okay. Yeah. So last thing, especially when we talk about Kubernetes in and on VCF, we are not just talking about TKC clusters. Right. There's multiple things that's you can actually use. You can use vSphere pods. You can use VM service. As you can see, these 2 VMs that are created over here, right? One Photon and one Ubuntu. These are created by VM service. Okay. So that's the last demo I'm going to show. Okay, let me log on to the soup cluster. Okay. Now I'm in the supervisor control plane, as you can see over here. Okay. And I'm going to show you, VMs that's been created. Right. So you can see that these are the TKC clusters, and these are the 2 VMs that I created, right? So you can see in vCenter, you can also see it on the CLI itself, right? So you can specify the images in the content library. You can actually create your own image and upload to content library, and you can actually use the Kubernetes API to create the service itself. Okay.
Can you actually demonstrate that to create, let's say, one virtual machine through this service and then also load balancing?
Yeah, sure. That will take some time. So, okay, let me try a Photon one. Okay.
Yeah, the simple, like very small footprint one.
Yeah. Okay, let me create another one. Right. So basically, I'm going to call it VM2. Same name, same namespace.
Same everything. Yeah,
I'll just keep it the same, just a different name. All right.
Yeah.
And yeah, there you go.
What is that KAF?
So basically, it's just shortcut for me for kubectl apply -f, right?
All right. Okay, got it.
I put it in the shortcut, right? So
Yeah. I like that. Yeah.
So you can see, this is the VM service. I've created the VM over here. So again, you will fetch the image from the content library, and you actually create over here.
Really cool way to interact with virtual machines, right? From within the TKG clusters. Awesome, man.
Correct. The use case for this is like, you could have microservices running in your TKC clusters, and then you probably need a database, right?
Yeah.
Or you just need VMs as a service rather than container. You can actually use this VM service.
Yeah, maybe something that you want to have it persistently. That makes sense.
Yeah, because I'm using a netted topology over here, and the way you want to get access to the service, right?
Yeah.
To the VMs, you actually have to create a load balancer service, right? So, like for example, if I want to do SSH over here, actually needs to create the service for it, right? And then associate it with the VMs. And again, you will actually use the RV controller for it, right? So you can see all this address over here.
Yeah.
Okay, did it in the virtual service itself, right? Over here. So this is the first one that I created is actually showing over here. Essentially, you can use the RV for VM service as well. That's essentially what I want to show, right? So not just TKC, you can also use it for VM service, even vSphere pods, right? You can also use it for it as well. So now maybe let's take a look at, I remember I scale out the service engine, right? Let me see, is it this one? Yeah. So as you can see, I have, previously there was only 2, and I successfully scale out third one, right? And remember there was the DXXKG, right? So, what I say, you can easily scale out your service engine for all your different applications that's running in your platform, right?
Exactly. This is good. We covered all of these 5 demos in a very short time, right?
I hope I did that.
No, this is really excellent, man. I really liked what you showed us. Yeah, so this is, like I said, really all-rounder load balancer here with Abby, which can do the control plane balancing, the workloads load balancing, and also the ingress control, and also for VM services, right? Super cool demos, man.
Yeah, I'm just barely stretching the surface over here, Satya. Like, there's much more things that you can do with RV, the multi-cluster setup that you can do, and, enabling WAF services. I'm sure that you try to Google a bit, you should be able to find demos on all those videos. So do check them out as well. But there's much more capabilities that is out there. Yeah.
Absolutely, man. I mean, like you said, we just scratched the surface here. We just looked at the tip of the iceberg. Heavy load balancer itself is such a great enterprise-grade load balancer with WAF, analytics, all the orchestration, everything, right? And automation inbuilt. So absolutely, for our viewers, please look into more about Abby. There are lots of practical demos and lots of resources out there that you can use Abby for using its full potential. Awesome, man.
Yeah,
thanks, Vincent. Really good, bro. Really appreciate all the things that we have done here. Let's wrap up this episode here, and we'll be diving deep into TKGs cluster and how it is deployed and managed in VCF next time, isn't it?
Yeah. So like we give a little snippet about it just now, but let's deep dive into it in the next episode. Like give it justice, right?
Absolutely, man. There is more to come. So thanks, Vincent. Really appreciate your time today, man. Really appreciate it.
Thanks for having me.
And thank you to everyone, all the viewers. Thank you very much for staying. Thanks for watching. And we look forward to seeing you in the next episode. Bye for now.
Take care. Bye.